Okay, last week we were working with limits and derivatives and finding the slope of a tangent at a curve. Now, we did them a lot individually to find the slopes at exactly one point, and with some other people I used a proof to prove for any point on a graph. If I had some point x, then some point a little bit away from that would be x plus h. And the points on the graph would be, this point would be x, x, and f of x. And this point would be x plus h and f of x plus h. And what we would do is find the average slope between those 2 points right there. So it would be f of x plus h minus f of x over x plus h minus x. And what I told everyone we're going to do is I really want these 2 points to make it instantaneous. I want these points to be really close together. So I'm going to say it's the limit as h approaches 0, meaning h is going to be so small that these 2 points are essentially right on top of each other without actually being there. So this equation is actually the definition of a derivative, which is the slope at one point exactly. And there's something I noticed on the bottom. I have x plus h minus x. So these things can cancel out. So for any function, I can find its derivative by finding the limit as h approaches 0, f of x plus h minus f of x all over h. So how am I going to test this out? Let's pick a function. Let's take the function f of x equals x squared. So I'm going to find the limit as h approaches 0. I'm going to put this into the function that goes into there of x plus h squared minus x squared over h. If I was to then FOIL that thing out, it would be x squared plus 2xh minus h squared minus x squared, ooh, it's terrible, over h. And that x squared cancels out with that. So I've got the limit as h approaches 0 of 2x h minus h squared over h. If I fill in 0, I get 0 over 0, but I see every term has an h in it. I can cancel those out, and now I substitute in the 0, and I get the limit is 2x. That tells me the slope at any point on the curve of x squared. We're going to learn some terminology for that and see how that relates. Now, I'm going to show you the steps for a bigger one. So I'm going to set up the equation for when f of x equals x to the 6th. So it's going to be the limit as h approaches 0 of x plus h to the 6th minus x to the 6th over h. Now, this may look like it's easy, but I have to do x plus h to the 6th power. I'm not going to have you do that. I'm going to work all that out right now. Oof, I worked that all out for you. So that will actually FOIL out into that. It's not actually a hard process to do. And on the front here, I have x to the 6th, and I have negative x to the 6th written over there. So now I notice everything has an h term in it. I can cancel one h out of everything. And now I can fill in when h is 0. Well, I'm left with the 6x to the 5th. Well, if I fill in 0 for here, this thing is gone, this thing is gone, this thing, everything's gone. So the derivative of x to the 6th is 6x to the 5th. Now, I never really had to do any of this work. There's a nice shortcut. We talked about it in class today that will always work to find the slopes of a function. Okay, so to prove that you completed the homework assignment, you'll complete the information on the page right here. Okay, I'll see you tomorrow.